Hi, this is Michael Schober from the New School for Social Research in New York City. Today, my colleagues from the University of Michigan and the US Census Bureau and I will be presenting analyses we've been carrying out to better understand when and how social media analyses can and can't augment public opinion surveys. We'd like to thank the Summer at the Census program for helping us to learn about potentially available data sources. This laid the groundwork for the analyses we'll be presenting. And of course, the views expressed in this presentation are our own and not those of the Census Bureau. For a number of years, there's been great interest in whether and how social media analyses might augment or even replace surveys. Early promising demonstrations suggested that analyses of social media content might well align with measurement from sample surveys, even though a social media corpus is not designed to represent a population, or designed at all, in Groves' sense. Famously, O'Connor et al. In 2010 demonstrated significant correlations over time between the sentiment ratios of tweets containing the word jobs, Gallup's Daily Economic Confidence Tracking Poll, and the University of Michigan's Monthly Index of Consumer Sentiment. You can see that the patterns more or less go up and down together, though not perfectly, which is either surprisingly high if you don't expect any correlation or moderate if you're expecting perfect correlation. But then sometimes survey and social media findings don't align. For example, Jungherr, Jurgensen, Schön restored tweets mentioning the Pirate Party from a corpus analyzed by Tumastian et al., and now sentiment analysis falsely predicted that the Pirate Party had won the German election. From our team, Conrad et al. Found that correlation of jobs tweets and the index of consumer sentiment studied by O'Connor et al. Did not extend into a later time period, was not robust to changes in the sentiment analysis method or other data processing decisions like smoothing and lag, and in fact, removing clearly irrelevant tweets made the associations worse. This suggested that the original finding was so fragile that it was likely spurious. As we see it, the jury is still out on when and how social media data and survey data will align. We need better theory about when they're most likely to tell us the same things about society, and to get clearer about how to avoid spurious findings. As we see it, survey and social media data are so different in nature that they could easily not align, but it's possible that under the right circumstances they will, when they tap into similar processes. So our project is trying to identify the circumstances under which social media and survey findings might plausibly align. The current investigation explores two propositions about when alignment should be more likely. First, the proposition is that alignment should be more likely for survey questions whose responses over time have a good signal-to-noise ratio, which we define as good signal, responses actually change over the time frame, and low noise, the sampling variability can't be too high. Second proposition is that alignment should be more likely using social media metrics that are suited to the question content. So the frequency of tweets with particular content may be informative about the volume of discussion, but uninformative about the valence, how positive or negative the sentiment is. We argue that sentiment analysis should be particularly suited to alignment with survey questions about sentiment, but not necessarily about other kinds of questions. Our domain of investigation is knowledge and public opinion about the US Decennial Census from January to September of 2020. This domain gives us an unusual opportunity for exploring our propositions. First, the content of the survey includes both behavioral and attitudinal questions on a range of topics during a period of societal controversy about the decennial census. We have daily measures over 9 months available from both the survey and social media data sets. And the ongoing monitoring of social media content within the US Census Bureau provides excellent access. Our survey data set comes from the 2020 Census Tracking Survey, which asks questions about people's knowledge of the census, their exposure to ads and word of mouth about the census, their likelihood of participating, their trust in data privacy, their beliefs about uses of the data, and so on. We analyzed about 77,000 web survey responses from January 1st to September 13th, 2020, which produced daily estimates from about 300 households per day. The data come from two opt-in non-probability panels. in a sample selected to match American Community Survey quotas on a range of demographic variables. We also have access to tracking survey data from a probability sample telephone dataset, but these data are for a shorter time period, so we're focusing on the web survey data. We'll look at the telephone data in future. Our social media dataset consists of about 3.5 million tweets from January 1st to September 14th. The dataset consists of all tweets that mention the US Census and related content on each day. It is collected via a complex query designed by the Census Bureau through the Sprinkler platform. Here on the right, you can see the start of that very complex query. Our measure of alignment is comovement, the fraction of time that two time series move in the same direction. This measure ranges from 0, which would be perfect anti-association, to 1, which would be perfect association, with 0.5 being chance association. Compared to the Pearson correlation, comovement is less sensitive to outliers because the method is non-parametric and robust, and less likely to detect spurious alignments in time series that correlation can find. For example, if two time series both exhibit a long-term increasing trend but are otherwise unrelated. Comovement requires specifying a time step, for example, 1 day to 1 day, or a week to a week, or a month to a month. Here's an example of how comovement works in the best case scenario of comovement, that is, a split sample of responses to the same survey question from our dataset, randomly split on a daily basis. So as you can see here, the responses track very closely, as they should because they're from the same dataset, but not completely perfectly. So what's the right time period for assessing alignment with these survey data? This visualization plots comovement over different time periods for our split sample of survey responses, in this best case scenario where we know that comovement is quite high. The y-axis shows comovement ranging from 0 to 1, with 0.5 being chance. The x-axis shows the calculation of comovement over different numbers of days. Because you can start time periods on different days, for example, a week could go from Sunday to Saturday or Tuesday to Monday, this graph plots comovement calculated in each time period with multiple starting days, with the mean comovement plotted in color. We calculate whether the comovement is significantly different than chance, or 0.5, by using the binomial distribution. The cutoff for significance varies from time period to time period because sample size reduces for every increase in days. So 1 week has 1/7 the sample size as 1 day. So what this graph shows us is that we do not observe significant comovement at the level of a single day, which makes sense given day-to-day sampling variability. We start to see significant comovement for the 4-day window, with responses averaged over 4 days, and up to about 30 days. This suggests that looking at comovement over a sufficient time period, more than 4 days, less than 30, is what will be needed for this data set. To test our first proposition, we need to find survey questions with responses that actually change over the time frame and with not too high sampling variability. Our method is to screen all survey questions for measures of good spline fit, or R squared. Proposal is that we should only see alignment between survey responses and social media analyses for items with high signal and low noise. To test the second proposition, that selecting the right social media metric is important, we will test whether we can find the suitable metric for the high signal to noise ratio item at showing alignment, showing that an unsuitable metric does not show alignment for the very same question, and showing that neither metric shows alignment for a low signal to noise ratio item. Our question with a good signal to noise ratio is the question, how much have you seen or heard recently within the last week or so about the 2020 census? We'll call this the exposure question. So the y-axis plots the proportion of people who reported each day having heard anything, a great deal, some or a little, within the last week or so. As you can see, the spline fit is extremely good. The responses clearly change over time in a consistent way. Our question with a poor signal to noise ratio is, how concerned are you, if at all, that the answers you provide to the 2020 census will be used against you? As you can see, the responses simply don't change over time. So there's really nothing that the social media data could align to. So what did we find? The evidence we are seeing thus far is consistent with the propositions we're exploring. That is, comovement is high for this question that has a good signal to noise ratio and using the metric, the social media metric of frequency of tweets, which makes sense for a question about how much exposure people have had. The tweets in this case were weighted by recency, with the most recent tweets weighted more and less over the preceding 10 days. This was our starting method based on conceptual grounds, but the story is very similar if we use all the tweets unweighted. Consistent with our second proposition, for this good signal-to-noise ratio question, we do not see significant co-movement when we use a social media metric that is unrelated to the content, in this case, sentiment. There's no reason to assume that sentiment should be connected with exposure to the census. The question isn't about whether you like or don't like what you've heard about the census, but simply whether you have. Also consistent with our propositions is that our poor signal-to-noise ratio question with either metric, whether that's frequency or sentiment, does not show significant co-movement at all. We see no evidence of co-movement or alignment at all. So we see these analyses as providing promising support for this approach to thinking through when alignment is plausible or even possible to observe. We think it makes sense to examine the properties of the survey responses for a particular question and to select social media metrics that are suited to the content of the survey question. What we saw was high signal-to-noise ratio questions showing significant alignment only with the suited social media metric, and the low signal-to-noise ratio question not showing alignment with any metric. Our next steps are to test this approach with more survey questions and thinking through what the most appropriate social media metrics might be. And we recognize we need to define more systematically what appropriate means. The same survey item may have different meaning in different time periods, for example, before and after the launch of census data collection, and so different social media metrics might be appropriate for different periods. We also intend to test this approach with our probability telephone sample data, and we want to explore how fine-grained alignment can be using these co-movement measures. Both data sets give US state-level geographical distribution for all the survey data and for some of the social media data based on user profiles. So we want to ask whether alignment varies across regions or becomes greater. We see these analyses as steps towards our longer-term agenda of understanding more systematically when and how alignment between survey data and social media content is and is not likely to occur. As we see it, this is a prerequisite to realizing the promise of social media analytics. My co-authors and I will be working towards advancing this agenda through a cooperative agreement between the Census Bureau, University of Michigan, and the New School, in which we will spend time looking more closely at response distributions and properties of survey items, processes and dynamics that lead to social media posts, and how social media sampling methods and alternate social media metrics that focus on content, like topic modeling and more sophisticated lexical analyses, may affect alignment. Thanks very much for your attention.